Hello and welcome everybody to another Queensland AI Meetup, a bit of a special one this time. Rather than having a single guest, we're going to have a number of our community members sharing their projects from our Fast AI course that we've been running. So tonight we're going to try and keep a fairly quick cadence. We'll go through a little bit about the course itself for anyone who hasn't been involved in it and knows what's going on. We'll introduce some of our judging panel, and then we will hand over to our teams to present their projects and show you all what they've all been working on. So just for a little bit of a primer, the running of this course has really been put together from three sort of organizations. The first one, obviously, given that we're here tonight at Queensland AI, Queensland AI team, and particularly a bunch of mentors from the Queensland AI community have been involved in this course. So they've been really pivotal in helping the students move along and obviously just trying to help them get the most out of it. The Queensland AI Hub has been really key in bringing all of this together, really pushing to get this going now that Jeremy is back in Australia, and a huge help with a lot of the logistics behind the course, helping, get applications out and making sure that everything's happening, and running smoothly. And of course, the course itself, and by extension, Jeremy and Rachel, now that they're back in Australia, the core Fast AI team, obviously we wouldn't be running the course if it wasn't for them. And they've been really important in obviously providing the content, but also coming down and helping the students as well. We've seen Jeremy a couple of times down to work with students. So let's talk a little bit about the course. So this course that the Queensland AI community have been working on is really based around the existing content from the Practical Deep Learning for Coders course. So this is the most popular course from Fast AI. It's really, as it says in the name, designed to help get people who already know how to program, although 6 months of Python is enough to get you going and get into the course, but it's really designed to help people go from zero to building state-of-the-art deep learning models. To go along with the course, it's all built around the Fast AI Python library, which makes it really easy to build these models. And that, of course, wraps around PyTorch as the engine under the hood building the models or training the models. This course and the library itself is really built so that you can tackle most machine learning problems. So across a range of different domains. So tabular data, natural language processing with text, and sort of sequences, computer vision, and even recommendation as well. And you can also sort of extend the library to work with other problems, but really it's an all-in-one toolkit so that you can work on a bunch of different problems. And as you'll see tonight, there's a number of different applications that our teams have built solutions for. The course itself runs over 8 weeks. We had a couple extra weeks either side to sort of introduce the course and do a final sort of session with the teams. And yeah, like I said, created by Jeremy and Rachel. Jeremy is on the call and one of our judges tonight. If you are interested, obviously go check out the website. There's also some great other courses there that I can definitely recommend. So the course. So like I said, it's based on the existing Fast AI course. Essentially what we did is aimed to make the course about 50-50, the existing content that Jeremy has put together, and then the other half of the students' time was spent on building their own projects. And that's why we're all here tonight. So really, all of these students, it was a range of different backgrounds. A lot of them, aren't engineers. Some of them already do some software engineering, but it was a really diverse mix. We really tried to make sure that we had a broad range of people. And every week we had our in-person 40-person 40 in-person students coming into the AWS offices here in Brisbane. We also had hundreds involved online, although by the end of it, it was around the sort of 50 to 100 people online. And basically every week we'd hold a 2-hour session to go over that week's content, and the mentor team also put together some additional content to help walk through that content, build upon it, and also give some live sort of coding exercises so that everyone can learn along the way. And obviously, yeah, teams were built along the way to sort of not only learn the skills, but then put it directly into practice. And importantly, this isn't the first time the Queensland AI or Brisbane AI community has put this together. This is really building on the previous experience from some of the courses that were run back in around 2018 by, you know, a lot of the team who are actually involved in this one as well. So here's a picture of our in-person team. This is a mix of obviously our mentors and our students, and obviously taken in the AWS offices. It was, yeah, really great sort of coming together every Tuesday night and, you know, getting to know a lot of these faces, and obviously lots of different people getting to connect with each other and work on things together. So it was a really great time, really, really enjoyable. And hopefully when we run another one, we'll see these sort of numbers again or more. So team projects. So at the end of the course, once all of the fast AI content was complete, the teams had been working on their projects throughout the 10 weeks. And at the end, we had a total of 11 submissions from both in-person and online teams. In order to narrow that down so we didn't have too many teams presenting tonight, the mentors collectively went through and scored each of those projects. We've got the top 6 for you tonight. And the judging has been based on a mix of the creativity of each project, the technical approach and how it was executed, the general difficulty of the projects. So more difficult projects tended to get higher scores, and the presentation, because of course the most important part of building a solution, or, you know, when it comes to telling others, is communicating that clearly and presenting it well. So that's how the mentors have judged it. Our judging panel tonight is an all-star cast of AI, both, you know, obviously local AI community members. Our first judge is Jenny Davies. She is a solution architect manager at AWS, very passionate about AI, and, you know, being involved, there's Jenny there, you can see her, been involved in the space, particularly here in Brisbane, for quite a while. We've got Keay, who most of you have probably seen and met before. She is the CEO of the Queensland AI Hub. And we also have Jeremy Howard. Hopefully you all know who he is by now, but obviously the co-founder and creator of Fast AI and the course that all of our students have completed over the last 10 weeks. So they will be our judges tonight. They will be judging each of these presentations on a similar sort of criteria, but at the end of the day, it will be up to them who our winners are. So I'll let them figure out how they want to come up with that. What does this next hour and a half look like? So our teams are all going to be presenting their presentations. We're essentially giving each team a 10-minute block. Part of that 10-minute block will be around 6 minutes to present to all of us. We'll have around 3 minutes of Q&A from our judges for any questions or any feedback that they have, and then we will move on to the next team. So it is 6:13 at the moment. We should be done with those presentations at 7:15, and then we will be announcing our winners. And what do our winners win? Well, all finalists tonight will be getting an AWS swag pack, thanks to AWS. That will include a t-shirt, drink bottle, pen, stickers, and notebook. And the first place team will also be winning some AWS credits so that they can either continue working on their projects or go and build something else with what they've learned. So yeah, massive thank you to AWS, who have not only supported the course along the way, but also obviously helping pitch in to reward our winners who have worked so hard. So that is all from me. Now we will be kicking off and getting into the presentations. So our first team, who I will hand over to, is one of the in-person teams. Most of our finalists are from the in-person crew. This is the team CV1 in person, so computer vision. Take it away, guys.
Hello, Michael, thank you. I would just firstly sharing my screen. Okay. Are you ready, Stan?
Yep, all good.
Hey.
All right, good evening, everyone. We're very excited to kick things off this evening. First off, we'd like to thank Queensland AI Hub, fast.ai, AWS, and of course, our mentors for making all of this possible. Without further ado, Daisy Nguyen and myself, Stan Podums, would love to present our project called Garbage In, Garbage Out. Each year, 8 million tons of plastics are dumped into our ocean, and it's killing our marine life. Luckily, volunteer groups such as Ocean Crusaders and Sea Shepherds organize regular beach cleanups. While there are always dozens of volunteers, the process is a bit a hit or miss. So people start randomly scanning the beach for pieces of litter and hope for the best. With drones getting cheaper than ever and impressive progress in computer vision algorithms, we think we can make things a bit more efficient. So our idea is to fly a drone over the beaches and take aerial images. We can then process these images using object detection and get an idea of the amount and type of trash. Using the coordinate information in the images, we can then plot this information on a map and more efficiently deploy volunteers and focus on the places with concentrated and most threatening trash. To tackle any machine learning problem, we need good data and good tools. Luckily, we found a publicly available data set called TACO, which contains images and bounding box annotations for 60 types of litter. Thanks to the open source community, we also have great libraries that can fast track the training of our algorithms, especially PyTorch, fast.ai, IceVision, and YOLO have been very helpful in our process. So we have our data and great tools. All we have to do is just run some training. What could possibly go wrong? Apparently, I dress like a drinking can. Thank you, Mr. Computer. So in our first experiment, we had a lot of misclassified items. So we decided we needed to spend some more time improving our results. A key area was rethinking the way our data was structured. I would like to hand over to Daisy and to talk a bit about the original data set and the steps we took to improve our results. Daisy, take it away.
Thank you, Stan. Thing went wrong, to be honest. Thing did go wrong many times through many early possible experiments that we make on the raw data. So we seriously thought of taking up a closer look to the dataset and taking it into our serious consideration. Overall, TACO has 1,500 images distributed over 60 categories or mapped into 28 subcategories. The category distribution was extremely imbalanced in either way. So how do people usually deal with the imbalanced data? Too many pruning, a few oversampling. It doesn't sound easy busy, doesn't it? However, with the object detection, there is a high possibility that we see many objects in one image. So what does that mean? It means if you drop one image, you drop all the object. And if you replicate an image, you replicate all objects. So here we come to the solution. So given the short amount of time today, I will just wrap up into, firstly, we did manually mapping the categories. Secondly, we showed the problem of dare to drop and replicate by applying text mining technique. We picked up more problem on the way, obviously, but eventually we wrote custom code from scratch in order to get this data balanced. After all those efforts, we should be allowed to have a better hope for the outcome of the model, shouldn't we? Are you ready to roll? We ran YOLO 5 for 300 epochs in a super fast computer, and guess how long did it take? 13 hours. But have you ever just feel so happy looking at your boring terminal for hours to see the model start training 300 epochs? And then get just so excited to see the precision and the recall improve over the epoch. We did have that feeling, which was actually sort of awesome. all our effort of the data pre-processing were paid off. The result came out were remarkable. It did pick out the object, and the bounding box was precisely generated. But hang on the top left, if you have a closer look, you will see the first and the second image on scene. The model did not recognize. So what did we do to fix it? We went to the beach, we flew the drone, we captured objects on scene, we manually labeled them and fetched into the training. We ran another 300 epochs, and the most exciting part would be presented in a second. Stan, you ready?
Yeah, sure. Thanks, Daisy, for that. Before I actually show an actual prototype of our tool, I just wanted to show what's actually happening with object detection. So as you can see, our model is trying to recognize objects in our videos and images and creates a bounding box and a class for each of the individual items. So this was an earlier run. And in the next slide, we'll see some better results of that. Can we move to the next slide, Daisy?
Stan, I think the video is already played. Do you see it?
Okay. Yep. So while this looks pretty, we need to process this information a bit further to actually make it valuable. So here's the prototype of our actual tool. I think my video ran a bit behind, but here you see how we upload all the images to the tool. On the background, it did the object detection. It grabbed all the images with objects in it. We then plotted those images using the coordinates on a map, and you can see which trash is where. So while we had a lot of fun building this project, we'd love to put it to actual use. So we reached out to some beach cleanup organizers and have been invited to Fraser Island to put our tool to use so we can test and improve on a real world scenario and add real-time improvements. In the meantime, we also want to improve our model a bit further by experimenting with some relatively new techniques proposing papers, and also feed our model some more data. And we could actually use our existing models to help build this new data, to help label it, I should say. Since we're short on time, we'd like to conclude our presentation here and take some questions now.
Thank you very much.
Yeah, I'd love to ask a question if I can. Computer vision's something I'm quite passionate about. I'll go on video. Sorry, computer vision is something I'm quite passionate about and really enjoyed it. And I really enjoyed your learnings. The fact that, you need to train your model, or you need to run inference on images that are somewhat similar to what you've trained on. So those original images you kind of struggled with, and that's a really good learning that you've come up with there. I do have a question. How would your model deal with like a pile of rubbish? So it's not an individual chip packet, it's not an individual drink bottle, but sort of a mix of things. How do you believe it would deal with that?
That's a very good. Daisy?
Yeah. Thank you. That was a very good question. So if you have the power of all the object in the image, but it's what the main idea of object detection. When you have one image and you have even overlap the stuff, and how we work on it, because like because if you don't, you have the imbalance data. If you see the taco data set, you see the label, the model didn't have enough bounding box. So that's why we need to generate them more. And then the pre-processing for replicate the rare label, and then pruning the loss of label was just like a long process. But we apply the text mining technique. But if you want to deep dive into that one, so I can give more detail.
So did you need to introduce a new label, something for like a conglomerate of rubbish, or are you still just looking for those individual items?
Actually, the YOLO architecture already helps you to deal with the power of all the objects together. But the thing is, the YOLO, they didn't recognize if the glass, when you fit in the model, was just imbalanced. So it's all the legendary machine learning problem was the imbalance data. So we just need to fit them more label, but then we need to fit them in the separated image, then they can learn it. Then they can find out the box that really have the valuable information, and then they can just drawing the box.
Okay,
I
thanks.
think
All right.
I
think we are out of time. We'll need to move on to the next team. Judges, is that all you need to make your scores? Perfect. All right. So next up, Daisy, if you can end sharing your screen, is the in-person team Tabular 1.
All right, can you see my screen?
Yes.
Okay. I just want to make sure that you are seeing the video, but just give me a second. Let me share. Yep, I think that's the correct one. Okay, so hi everyone, I'm Tracy and I'm from Tabular in-person group 1. And today we will want to do this live, but because we really want to avoid any technical issues, as well as we want to fit it within the very short time frame as well. So we did pre-record ourselves. So now I'm just going to play the video and we will be back with you in the Q&A sessions. So let me know if you cannot hear the video. Thank you. Hello everyone, we are Fast Tabulars, and in the past few weeks, we have been working on our projects to predict quote conversion rate. So let's start with a very important concept, conversion rate. So for me, simply, this is just the rate of success when you take any actions. And this concept is relevant to all aspects of our lives. For example, when you want to apply for a job or you want to submit your group projects for this course, you would definitely care about your success rate. And if you have been collecting information of 700 people in this course, which will make you like a stalker, but you could also run a fast AI model to predict your success rate. And this is the same case for businesses because they want to spend their resources efficiently. They also care about conversion rate. So you have probably heard about marketing conversion rate, web conversion rate, or like in our project, quote conversion rate. So this is a Kaggle competitions, and they asked us to build a model to predict their success rate in quoting home insurance to customers. However, for this particular projects, we would want to focus less on making it to the top of the leaderboard, but more on creating a data products that can actually help businesses. So this is why we decided to take Jeremy Drytran's approach. So the first objective that we have is to predict the conversion rate for each quote. But what if your conversion rate is very low and you still want to win the quote? So our second objective is to give business recommendations to improve their success rate. As this is a Kaggle competitions, our data is kind of fixed. So we have information about personal, properties, coverages, and the quote conversion flag. But in terms of lever, we know that we cannot change personal or property information. Like we cannot ask someone to change their gender to give them like 10% quote discount. So the lever that we can control includes price, sales, and coverages. And in the end, we would like to create a model and an app that can help us to achieve the objectives. So how did we create our model? Our goals is to test all of the model possible and then share them with other people. So you can find the details of our models in our fast page blogs. And there are already like 20 posts for this particular project. So back to our model, the first step that we did was to do EDA on the data and then use fast AI functions to clean it up. And after that, we created our first random forest, XGBoost, and deep learning fast AI model. And the evaluation metric for this classification problem is the area under the rock curves, and the scores are in those tables. And we then use different libraries to find most relevant features. For deep learning, we use permutations analysis from work with fast AI. And we then reran all of our models with the new features. And you can see that the score only changed slightly, but we have to deal with a much smaller data set, and it is easier to interpret this data set. And we also optimize the hyperparameter of our XGBoost model with Optimus and deep learning model with Bayesian optimizations, also from work with Fast AI. And another thing that we tried was entity embedding suggested by Jeremy. So we pull out the embedded categorical variables of our deep learning model and use it to run the XGBoost model, and it did improve the accuracy score as well. And last but not least, we ensemble predictions from different models, average them, and the best score belonged to the ensemble of our XGBoost and deep learning models. So we put this result into productions. And you could easily see that deep learning model performed quite well compared to the other models for this problem. And deep learning also helps to improve the score when combining with other models. But surprisingly, deep learning on tabular data received far less attention than deep learning for computer visions and NLP, even though tabular data is the most commonly used type of data in the industry. So one of the inspirations behind our projects is to promote the use of deep learning for tabular data. And fast.ai tabular module has made it very easy for everyone now to run a deep learning model. All right, so I'm just going to pass this to Tim to show you our app.
We've created a tool from our model which will help the insurance company convert an unsuccessful quote into a successful quote. Here it is deployed to an Amazon T3 CPU instance. We can choose a quote number from all the quotes that are in the system, and our model will predict for us whether or not it is likely to be successful. Here is an unsuccessful quote. Our app performs a sensitivity analysis of all the available fields by changing one field at a time, trying a full range of values for that field, and predicting the quote success for each of these new values. The most sensitive fields for this quote are listed with radio or drop-down selectors and recommendations for the best values. For example, property field 29 is NaN, but selecting 10 will make the quote 100% successful. Property fields and personal fields are unlikely to be our drivetrain levers. So let's set property field 29 back to its original value and look at some less effective fields. Say we decided to change sales field 10 to 6 and sales field 5 to 1. Individually, they would improve probability of success by 21% and 46% respectively, which totals 67%. However, our tool shows that the combined effect of those two changes is to increase the probability of success to 72%. When we first set up the app, it took 600 seconds to call the 5,119 predictions required for each sensitivity analysis. However, by merging and concatenating the combination of field values into one data frame and calling getPreds just once, we reduced that time to 6 seconds.
All right, so that's the end of our presentations. And here are the pretty faces behind this project. So feel free to reach out for any of these people if you want to. And now we are ready for Q&A. Thank you.
Any questions, judges?
I was just wondering if you had a chance to compare your prediction accuracy to the prediction accuracies on the leaderboard of the test set.
Oh yes, so we had a chance to have a look at it, and I think our best model is around like at the top 30% of the leaderboard. I mean, because I think for us, the main goal of our project is to create a product in the end. So we do not really focus on increasing the accuracy rate, because in the leaderboard, the accuracy rate is already from like 94 to 97. So that's just a very small difference. And we would like to focus more on like building an app that actually works rather than trying to get that 1% difference to get to the top of the leaderboard.
Thank you.
Excellent. Any other questions? I think that might be all the questions. Good job, team, on the UI and app for that. Quite comprehensive, which is awesome. I think we'll move on to the next team, which should be what would Twain tweet? Which is a question I think we've all asked ourselves at one time or another.
Okay.
Hello, maybe share screen.
Tracy, if you can stop sharing your screen, please.
Yep, yeah, it is.
So
Stop, yep. Hello, everyone. This is Benaz, and this is my first experience basically with machine learning.
And my name is Jens, and I've been tinkering a little bit with machine learning in the past. And so today we're going to talk about our project.
Yes. So if you go to the website, so our project, as Michael said, is basically to determine, given a text, which classic writer would probably tweet like that. And so, for example, here, as you can see on our website, Mark Twain apparently in 1909 has tweeted something about artificial intelligence. For example, I like artificial intelligence because the material is not a product of inherited reasoning. It's a pity if you like. So this is one of the capabilities of our tool. As you can see here in the second section of our page, you can choose an author, for example, Charles Darwin. You can give it a different prompt, maybe here, like this green sea turtle is, and then you can generate a tweet. So it has tweeted something. Maybe it makes sense, maybe not too much. But also we have a classifier, which given a text, it will tell probably who might have tweeted something like that. In this case, it predicted that it's Charles Dickens, which is good. But basically, our model is not 100% accurate, so sometimes it's not labeling correctly. So we were lucky this time. In order to create this tool, I should mention that we built everything end-to-end from zero. So the first thing that we did was to create the data set.
Okay, so in order to build our data set, we went to Project Gutenberg, and every night they create a metadata snapshot, and which gives us access to 65,000 books. And for our data set, we were interested in only English books in plain text format, and which have valid authors assigned to them, which left us with about 35,000 books from 13,000 authors. So we wrote a program which automates the entire generation of the data set. And what it does is it fetches the data, cleans it up, and then filters through the entire data set as well. And we end up with about 1,400 books from 900 authors, from which we cherry pick the authors. And to give you an idea what that looks like, here we're generating the data set in CSV form for Mark Twain. And so it basically reads through the entire captured data set, builds the CSV file, and in a moment will be finished. We got 228,000 sentences to train with, and that's what we fed into our classifiers.
So we have a GitHub repository, as you can see here, and we have put the module that Jens just showed. We also have the website, and if you scroll up, yes, so we have the notebooks as well, where we have created the models. So in the notebooks directory, if you go,
oh, you want to go?
Yes, if you just go to the notebooks directory. So we have created language models for generating tweets for each author. As you can see, there are different notebooks for each author. And also we have a notebook for building the language model and then fine-tuning it to create the classifier. And we basically have used the fast.ai's pre-trained model, and which has been trained on Wikipedia, and then we fine-tuned it to on the corpus that we just talked about, and then basically we built our classifier. At the end, we achieved around 90% accuracy. So going back to the slides, in fact, accuracy is an interesting problem and metric for us because it's not too clear how we should measure our progress. So one thing we decided to do was to keep a test data set from the books themselves to compute the accuracy. We started with just 72% accuracy, and at the end we achieved about 96%. But I don't want to say that that's exactly going to make sense, because as you can see on the test data set, the accuracy can be a little bit lower. And also something interesting that we experimented with was to change the text chunks that we used from, for example, sentence to paragraph. And apparently our model is sensitive to the length of the text chunk. So for example, a paragraph classifier works better on paragraphs according to our test data set than sentences. So that basically concludes our presentation, and we are happy to take questions. Don't stop. Yep, maybe they have. Yeah, I was hoping you could give us a little more details on the pre-processing you did on the tweets. You know, sorry, on those tweets. Like, how did you deal with things like emojis and things like that?
Okay, so
the idea here is not necessarily the tweet. So we classify any text, right? So we use the tweets as a basically fun application. But what we did basically was on the book's text.
Right.
Yes.
So the books on Gutenberg are encoded at most in they're not all in Unicode, so there is no way to have emojis encoded in it. There's a phase or a stage in our not in the classifier, in our cleanup, in our data generator, which strips out exotic characters, and that includes non-textual characters. And there's because there's inherent Gutenberg has a format, a plain text format, which also includes how to emphasize text, how to add footnotes into books. All of that we've stripped out so that we went back to just the core text of a given book and stripped out everything that is non-textual.
If that answers your question.
Yeah, I have two quick questions. My understanding is you've built a generative model, so it's actually not just classifying, but generating the text. So my first question is how are you, what's the technical approach you're using to text generation from the model?
Yes, so basically we use the fast.ai's pre-trained model and the Wikipedia, and we fine-tuned the model over our data set. So it's basically using the for each author, and basically, yes, so it's using the transfer learning.
I understand how you trained it, but how did you do the inference? How did you generate text from a trained model?
So the language model itself, what it can do is to predict the next word, as far as I understand, based on the course, right? So basically what the language model can then do is that given a prompt, it will start predicting what the next word will be.
So you picked the highest probability token each time?
Yes.
Got it. And is this application somewhere online that we can play with it?
Oh, we would love to do that. Actually, we are already addicted to it.
So we're just wrapping and cleaning up the GitHub repo, and then you can run your own web server and play around with it. It's all documented in the repo.
I look forward to trying it out. You guys, in the meantime, should look up two things. One is beam search, and the other is nucleus sampling. Those should both improve your text generation.
Thank you very much.
You're welcome.
Any other questions, judges? Sounds like that's all our questions. Awesome. Thank you so much, Jens and Banaz. Yeah, cool project. We will switch over to our next team, which is audio, so mentor voice recognition. As we do, Jens, if you can please stop sharing your screen. Just a reminder, anyone in the audience, if you do have any questions or any notes on any of the presentations, feel free to ask them in Q&A and our teams can get back to you in there. Cool. So yeah, next team, mentor voice recognition. Feel free to take it from here.
Originally, our intrepid team of 3 chose to attack the frog detection problem on Kaggle. However, family matters and study requirements meant that we were unable to give the problem the time it required. We made the decision to change the rules. We would no longer try and identify what frogs were doing in the rainforest. We would, however, identify something much rarer and harder to find. Fast AI mentors. Little is known about the elusive Fast AI mentor. Rumour has it they can occasionally be found moving among the undergrowth in their natural environments, such as the Brisbane AI Hub, or even more rarely, the Amazon headquarters. No one knows exactly what they drink, but curiously, they have been observed devouring pizzas delivered by red-headed Amazonians. Mostly they are known to be solitary creatures, sunning themselves by basking in the glow of a multi-monitor setup and warmed by expensive graphics cards. Recently, a number of them were spotted giving presentations to a mostly younger group of inexperienced fast AIOs who were keen to devour their knowledge. Luckily, our scientists made videos of these rare gatherings, and now we must leverage these recordings to produce a model that can be used to identify them by name or number, should they ever be heard or seen in the wild again. So come with us, if you dare, on a journey of sight, sound, and mind. It is time to leave the comfort of your desk. Next stop, the Fast AI Zone. The aim of the project was to use the recordings of the mentors to produce a model that could identify them by their voices alone. A standard approach to sound identification is to take short bursts of recorded audio and turn them into visual representations called spectrograms. A spectrogram is a visual representation of the spectrum of frequencies of a signal as it varies with time. The mentors had given 10 Fast AI lectures. We downloaded them from YouTube. We then extracted the audio and used subsets of the audio to create spectrogram PNG files of audio clips each 3 seconds long. We did that for every mentor. We also added data augmentation techniques of pitch shifting and adding noise to increase our training set. We used the Librosa and PyDub Python libraries to carry out the audio extraction, augmentation, and creating the spectrograms. We used approximately 20 minutes of audio per speaker, leaving us with extra audio for post-training inference. We were then able to use the PNG files we created to train a ResNet 34 image classifier using a standard FastAI CNN learner. Once we had our model, we were then able to use the inference audio we had set aside earlier for extra testing. We then built a video inference system so we could pass it an MP4 file to it and have it tell us who it thought was the main speaker. Here is an example of the inference in action.
This notebook serves as a visual demonstration of a potential inference pipeline for our trained speaker identification model. We start by loading in the dependencies and the test video. We're using a 1-minute clip of Olga from week 4. We've already trained the learner for prediction, so we load that in first, and then extract just the audio using FFmpeg, followed by Librosa to load the waveform into Python. Here's the first second of audio. The model was trained with overlapping windows of 3 seconds of audio offset by 1 second. So for our 60-second clip, we'll perform inference on 58 slices. The slices are used to compute the MEL spectrograms, which are then transformed and rescaled as decibels to normalize them. The getImage function helps to prepare the signal for the model. The image data for each spectrogram can be stored temporarily in a buffered stream and loaded back into memory. I've shown the first image here. We then perform batch prediction and borrow some logic seen elsewhere in fast.ai to get the class label for each slice's forward pass. Our overall prediction is the most frequently seen label. The model predicts 4, which is the correct answer.
This brings us to the improvements we can make. For most of the mentors, there isn't much audio available to use. So to improve our model, we'd need more audio of each subject speaking in a variety of situations. With this in mind, we've asked ASIO and the CIA to start tracking them. We'll let you know how they get on. One future option is to transcode the audio at various levels to help prevent the influence of where it has been sourced. For example, a personal microphone at home or, the setup at Amazon. Real-time or offline process speaker detection on a per-second basis is also something we could do, which would allow the label to change during the video. We'd also like to explore whether we can adapt the data set given to the CNN learner to handle a dual channel image, where the signal magnitudes and signal phases are passed in simultaneously. Embedding the speaker label directly to the video and streaming the results to the user is also something we'd like to investigate. But if we keep doing stuff like this, then Yako would be out of the job. And we quite like Yako. Lessons learned. Life happens. We didn't have the time to attack the original frog detection problem properly, so we pivoted to another, easier to solve problem. We would have had better results earlier on if we had asked more of our mentors at an earlier stage. That being said, we'd like to thank Yako for his help.
All right, thank you, team. Judges, do we have questions?
Just ask a quick one. This is fantastic. So talk to me about the applicability of this to not just listening to people talking, but for detecting, particular frog noises or perhaps, dogs barking.
Yeah, so with the dogs barking one, it's interesting. If you've got a noisy dog, the Brisbane City Council, for example, hang on a sec. Come on, buddy. If you've got a noisy dog barking, the Brisbane City Council want you to do things like record how many times the dog barks in an hour and things like that. I, however, have a noisy 10-year-old who wants to make himself part of a video, so I might be recording him. As far as the frogs, etc., go, well, you can use it for ecological purposes. Let's say you've got a piece of forest that you're going to, you might want to build a hotel or something in. Well, what kind of animals live there? Are there any endangered frogs or any other creatures there? Well, if you build models for these types of animals, you can leave a recorder out there over the long term and then play it through your model later on to identify anything you might have.
Did you guys look at all at using fast audio or torch audio? And also, did you consider fine-tuning a pre-trained audio model?
We wanted to keep things as simple as possible. So we did look at the fast audio thing. I do most of my development on a Windows box. I had trouble getting the fast audio going on there. So I just stuck with the Libroso and PyTorch libraries for that.
And the second part of the question was, did you look at, or did you do any transfer learning fine-tuning from a pre-trained audio model?
No, I did look around for some, but I didn't really sort of find anything that was that I thought I could use. So I just stuck with using using the ResNet 34, fine-tuning fit one cycle technique. Mitch sorry.
I was just going to continue that answer, that the ResNet we used is just the default weights, which I believe are from ImageNet. So definitely somewhere that we could look to improve with supplying that for transfer learning from an audio model.
Yeah, there's not a lot of pre-trained audio models out there, but there is a lot of audio data out there. So I would guess that you would find that you'd get better out of distribution results if you used some of that external data to do a pre-trained model.
Team, did you try any different CNN depths? It looks like you used a 34. Did you try any others?
I'll let Bryce answer that. He's done a lot of the early processing and training stages. I think he did do another one. Is that correct?
I have a feeling Bryce might be frozen.
Oh, okay. I think you're right. Yeah, he did mention to me that he tried using a ResNet 50 as well. I believe it's just those two. And then following that, he told me there wasn't a very large improvement. So we just resorted to the 34.
Yep, thanks.
Awesome. Any other questions? All right, sounds like we're good to go. Thank you, team. Very cool application. Looks like it worked pretty well on all of us mentors, so well done. Next team is one of our online teams, the only online team that made it through to the final 6. This is, well, as you can see on the screen, semantic search for book recommendations. Take it away, guys.
So, hello everyone. We are the semantic search book for book recommendations, the NLP Online Group 4. I am Adilson, and I'm here with Camilo and Kamlesh. Here are the contents of our presentation. First, you are going to see what did we do, and the data we used, and the methods, our key application, and how did we do it, how did we structure our product, and what is the way forward? What do we think we can do in the future in the product? First, we used this data set called Amazon Reviews dataset that has more than 2 million descriptions of books, and also have reviews from the books, but we just use the descriptions. One other thing that our main thing here is to use the input from the user and give to him or to her, to their 10 books of recommendations. Now Camilo is going to explain a little bit about the structure of our project. And here is the interface of our project.
So how did we do it? We designed this little diagram to explain a little bit. We have 3 main components. We have a user-facing Streamlit app. So in that one, we will demo it later. So the user has the text box where he can put just a short description. In this case, we just put a book about boy in a wizard school. Then we have the text processing pipeline. So just tokenizing the text, turning it into a numerical form. And then we feed that into a deep learning model. So we used both the fast.ai AWT LSTM model, and we also have a Hugging Face sentence transformer. So we don't use both at any given time. We just use one, but with simple changes in the code, we can use either one of them. So after feeding the numericalized text, we get an embedding for the sentence that the user put. And depending on whether we use the sentence transformer or the fast.ai language model, we get a different dimension embedding. But the approach that we use is the same for both. So Kamlesh will explain what we do with that sentence embedding.
So yeah, so we get from from sentence transformer embedding, which is size of 768 in length. And what we realize is that this is too big when we put it in a memory. So we kind of applied a PCA on top of it to reduce it to 100 size and still having 95% of the information intact. And we use this embedding, we load it in the memory, and whenever a new sentence or new search item comes, for now we did just a cosine similarity, and from cosine similarity we get like a top 10 items. We can also take more, but just for the speed purposes we limited it to 10 items. And then once we get those top 10 items, we give it back to the user with the scores and the book titles with the scores. So this is based on the description, so they get the title for that, and then user can say, okay, was the search useful or not, was the recommendation as expected or not, and then we take their feedback, save it in the database for the future improvement in the search, which we are currently can improve further. And we also save the top 3 items in the database, like what we gave top 3 items in the search, so we know later that what was the user's outcome. So that's on this. Back to the slide. So we what is the way forward? So currently we implemented our whole approach only on the Amazon books, just to keep it small, the data set, but we would like to extend it to the whole data set of Amazon and not just to books. We would like to add additional data processing, pre-processing steps like weightage for some words or category pre-selection based on the criteria. We would like to also take the user feedback into the pipeline and improve our search over time. AI ethics here, like we would like to save the user profile, which is the next item. So maybe it doesn't give like if the woman is searching, or it creates kind of a profile that they get only certain type of book based on the content, but it's kind of adding some randomization that way. It's not going always in a certain way for certain people. So adding that part from the ethics. We would also like to save the profiles to individualize the search to the people. Add bit more rules and heuristics. So maybe the search directly out of the algorithm might not be good, and it can be added furthermore, so in case to increase the sales or something. And we would like to extend the user feedback pipeline. So that's all, and I will hand it over to Adelson so he can do the demo.
So here's our Streamlit app. So as you can see, the user can search a description here. For example, boy from a wizard school. Then click here on search. Here we have also the links for our data set into the GitHub repo. So the user will have 10 recommendations. And for example, the user can click here to search on Amazon and see the product on Amazon, and if he decides to buy it, or he can click here on the Goodreads to see the reviews about the book, and also has the score. So for example, we also get the feedbacks from the user. So if the user clicks yes here, we are going to save the feedback of the user on a Django server that is running on Heroku. As you can see here, we save the reply from the user, the response from the user, and the 3 top highest recommendations here. Camilo will send the link about our app, so you guys can try it out here. But that's basically it. Thank you.
I wonder, would you mind clarifying? You said that there were ethical concerns. I didn't quite understand. What were the ethical concerns you
so can
were
we, like, if sorry, so it's based on the search, right? So what people search, and we will save users profile also in the future. And this is based on the model which is pre-trained. So it can be that it is giving always certain type of embeddings, like somebody searching maybe something which is not, I don't know, like Adolf Hitler or something. And currently we are only restricting it to books, right? Once we increase it to more segment, maybe it's good to track it out. Also might be if we are saving the profile, then it kind of starts recommending things based on what it learned, like certain type of user always search certain things and try to give them similar ratings. For example, if the women get only for, I don't know, childcare and all this kind of recommendation rather than career and all that. So something like that. So we have to see it in the data, right? If it comes forth or not, but just to keep it in mind, because we showed it to some people like this search, and then they started searching some strange stuff in there. That's why we thought it's a good point to keep in mind.
Okay, thanks.
Does that answer your question?
Yeah, it's good to see you considering ethics. I was just wondering the angles you were taking that at. That's fine. I think Jeremy's got a question.
Yeah, it's good to see you, showing an example there, but I was surprised that I was expecting the example, obviously, to show Harry Potter as the result, and the result it actually showed didn't seem to have anything to do with the search. What was going on there?
Yeah, I used the wrong query. There's a query that responds Harry Potter. I'll try again. I think it's wizard from.
So even when we
the
get
boy
the
in Magic
Harry
School,
Potter
it is, I
book,
think.
Boy in Magic School, yeah.
Even when we get the Harry Potter one, you will see it's not one of the main books. So we didn't have time to actually go through the 2 million books to see if Harry Potter is in there. But you see the one that we get is like a coloring book or something like that. So maybe Harry Potter is not even there, but our intention was that, yeah, that was the example, and that's why.
So we are not sure, right? If there are all these 7 books of Harry Potter and there are 8, and if they are there, and the beast creatures and all that. So.
I just wanted to let you guys know, by the way, that I'll drop a link in the chat, but for searching for things with a good cosine similarity, there's things called approximate nearest neighbors libraries, which I think you guys would find really helpful.
Do you mean the FAS one? FAIS?
Yeah, you could use that, or NMSlib is the one that we particularly recommend.
Yeah, that would definitely help to speed it up.
Yeah.
Awesome. All right, sounds good. I think that's all the time we have for questions. If there are any others from the audience, feel free to put them in the Q&A section. With that, we will move on to our final team, which is an in-person team with computer vision, which is Cat Tensor's team. Take it away, guys.
Oh, is that us? Is that our name? That's a great name.
There you go.
Thanks so much for having us tonight. So we decided to do a video recognition problem. And thank you very much for the team. It was a pleasure working with everyone. So the problem statement we kind of presented ourselves on week 1 was, well, how might we control what content is displayed in a real-time video stream? And you might think, well, hang on, that's not really that interesting, but just a week before, I'm not sure if you're familiar with Cristiano Ronaldo, he's a famous soccer player, but he actually cost Coca-Cola $4 billion in one day because he moved a can of Coca-Cola out of the screen. And I thought there must be something to this. Like, people must want to be able to control what is actually displayed on a video feed. And some numbers here. What we just done was figured out, well, how much does it actually cost to run a 15-second ad on the 7 network? And it turns out it's about $22,000 for 15 seconds. And it became very clear that maybe there's something in this around being able to control what's displayed. So our project aims to detect and obfuscate brand logos on clothing within a live video stream. And I guess initially, to start with, what we wanted to be able to do was actually focus on the AWS logo. But we found it was just a bit difficult to actually get a test data set to be able to train it on. So in the end, we chose Nike. So how do we go about solving this problem? Well, first off, we go, well, has somebody solved this problem before? Turns out they have, but it's not very good. Second thing is there any publicly available data sets? And if you break that up into 2 categories, we've got people, sure, there's going to be a lot. But what about the Nike logo? Well, there wasn't. And so what we done was first prepared our own data set. And I'll go through some steps in that. Once we had the data set, we trained the model, and then we conducted the inference, and then we optimized. And I guess the key takeaway from the implementation for me was simplicity. Just keep it as simple as possible and get it working end to end. And at the very least, we show you a very bad thing that works, rather than a bunch of really good stuff, but we never actually got to the end. So I'm happy to say we got it actually working very quickly. And then what we're able to do is just incrementally improve it over the coming weeks. So in terms of gathering data, you'll be surprised, but we only actually used 600 images to train this model. 350 of those were the Nike logo, and the remaining were images of people. We used a open annotation toolset called Label IMG, available on the internet. You just run it on your local machine to actually do the annotations. And the key takeaways here for me were the power of augmentation. So we only had 600 training images, And we were able to augment those images and get a really, really good result. And the advantage we had here was we didn't go out and try and do thousands of images on day one. We actually started with about 100, didn't really get the result we wanted, 200, 300. And once we got to a point where we felt the model was good enough, we stopped and moved on. In terms of model and architecture and training, we did try a number of different models. You can see there we tried 3. And what we found very quickly is there's trade-offs between each of the models. And in the end, we landed on model 3. I'm hoping as part of our live demo, we can show you that we actually have the option in the web client that we've built to switch between which model we actually want to do the inference on. But as part of our training and testing and validation, we were able to determine that model 3 was by far the quickest and the most accurate as well. We also did build on top of the IS Vision framework, which is actually just built on top of fast.ai. So it's just an abstraction layer, and it was very cool. And thank you for the mentor that recommended that. It saved us a lot of time. Alrighty, live demo time. Nazi.
I'll need you to stop sharing first, Scott.
I'm trying to figure out how to do that. There we go.
All right. Okay.
So before this, we did debate with the team, do we show the pre-prepared? And we thought, you know what, we're going to go live demo.
Can everyone see that? So it's a webcam feed. Yep, so this is a webcam feed currently on my Mac. So we are feeding in frames from our webcam feed into our program. So that feeds into our YOLO V5 model, which is then figuring out the bounding boxes for a human, so that's me over here, and the Nike logos that are being blurred out currently. So our program's designed to only blur out Nike logos on items of clothing and humans. So if I bring up another Nike logo up here, that won't blur out. So yeah, that's our demo. I will give it back to Scott.
Cool. All right, last slide. So what are some outcomes and real world applications of this? And I think if you kind of abstract away, oh, I'm not sharing. There we go, got a slide, there we go. If you think about what we've actually built, so we've decided to obfuscate based on basically where bounding boxes were located. But the capability we've actually built is, we're able to detect a custom object based on our own, but we can also do stuff depending on where those bounding boxes are placed. So you could imagine we may want to do a count every time a bee lands on a flower. There's a number of other business applications that we could actually build this model out for. But the key one we wanted to look at here was screen time as real estate. So whatever's on a screen, we want to make sure we've got control over it. We may also decide to obfuscate selected elements within a video. Example there would be nudity, some violence. Some other ones I come up with was unwanted photo bombers in the back of your pictures. Or maybe some like ex-partners from your favorite images or videos that you just don't want to see anymore, and you just decide to kind of obfuscate them. And you could probably do that in real time as well, which is pretty cool. But as I mentioned, you could build on top of this as much as you want. And it does have real tangible business applications. That is it. Q&A time.
So just a question about, you said if the logo's on top of a person, you don't blur it out. So are you just running a person and a person detector as well as the logo detector and just correlating location of bounding boxes? Have I got that right?
It's the same model, and that's the advantage. It's the same model. So we have the same model with basically 3 classes, and all we're doing is saying, what's the bounding box of a person? What's the bounding box of a Nike logo if they overlap? And what we also have is a percentage. It needs to overlap with a certain percentage before we obfuscate it.
Great. Just with the augmentation, how much rotation did you allow for in your image augmentation?
What did we do? There was a bit of a trick there. So we did the rotation. Whatever the default setting was within I forgot the library, what it's called. But what we did remove was the interesting thing with Nike logos is on shoes, they're actually back to front. So, but the Nike name will never be inverted. You won't get an image where the Nike name's in, but it always happens on shoes. So we had to be careful about the augmentation, because sometimes the augmentation would augment it in a way that you'd never actually see it in real life in that manner. And so as we started to do these augmentations, we had to be realistic about, well, hang on, we'll never actually see it like that. And that was really important for accuracy. Any other questions?
All right. Any questions, judges? It sounds like that might be it. All right. I guess that is it. So thank you, teams, for your presentations. Lots of awesome presentations in there. Now we are going to give the judges 5 minutes to decide on who their top 3 is. I'm sure they're collaborating right now to figure out what that looks like. In the meantime, I'm going to take 5 minutes to basically just share a lot of thank yous, because this course is, I think taken, essentially 3 months to put together, a little bit more, which probably the fact that it's only 3 months and 10 of those sort of 13 weeks are the actual course sort of speaks to how quickly this came together and how responsive a lot of the key people had to be to make this happen. So yeah, let's go through and I just want to thank, a lot of the people who've been involved in this, because as we've seen tonight, there's been some amazing teamwork and skills that have been built over the last few months. So first of all, I'd like to thank Amazon Web Services. AWS came on board very quickly and helped to not only get some space available for us, but also help support, all of the in-person teams with AWS credits so that they could actually work on their projects and in a cloud environment, which was one of the sort of secondary goals, to have teams comfortable working in the cloud rather than just on their own machines. They're also contributing prizes for tonight's winners. So I just want to thank AWS for coming on board very early and, being extremely organized, particularly GEMS for, being there every week and supporting the program. Secondly, Queensland AI Hub, as I mentioned earlier, they were really pivotal in the organization of the course. Getting all of the applications involved, from forms to sign up, getting AWS involved early on. Obviously Sue here tonight and Sarah Jane helping with, actually making the meetup run. So, they not only support this course, but also the meetup. So I just want to thank them for, really helping make this happen and prodding us to get this to happen. And finally on this slide, Max Kelson. Max Kelson is a little bit of a silent supporter of the meetup. Personally, I work at Max Kelson, but we really want to make this meetup and this course really about the community. But Max Kelson is a supporter of this meetup and has been for over a year now, making this happen. So just want to say thank you to the Max Kelson team. Next, I really want to thank our mentors. This wouldn't have happened without the mentors. The mentors have committed, a huge amount of time and energy to make this course happen. Obviously, we have the course from Jeremy, where there's been a huge amount of time put into that and the Fast AI library itself. But when it comes to actually helping these students move through the course every week, tips and tricks on their projects, and just additional experience from the field that isn't as easy to find online. The mentors have been critical for providing a lot of that guidance and helping our students move along and make a lot of progress. So I'm not going to call out every name individually, but pretty much every one of these mentors has contributed a large amount of time and a bunch of their own experience to additional information and content for our students and helping them move through their projects. This wouldn't have happened without the mentors. It's just not possible. So huge thank you to all the mentors for your time and your energy. Yeah, massive thank yous. And I know that I've learned a lot from a lot of the presentations as well. Next, obviously, I want to thank the participants. You know, watching the presentations tonight has been fantastic just to see what you guys have built. You know, most of you have full-time jobs. A lot of you have families to look after, you know, and most of you don't live in the city, and it's not easy for you to get to the weekly sessions every night. So there's been a huge commitment from all of our students, particularly, you know, a lot of the teams who got through tonight. So yeah, most of them have probably committed to 8 to 15 hours every week on top of their full-time jobs and whatever other commitments they have. You know, a lot of them don't have any prior experience with machine learning and data science and have had to figure that out along the way. You know, most of them have full-time jobs, family commitments. Even one of our students is in their final trimester of pregnancy. I'm pretty sure they're still in their final trimester. I don't think the baby is birthed yet, but as you can see, you know, a full range of different challenges to get through this course. So a massive effort for you all. And, you know, I think the key outcome here is that for all of you moving forward, you've now got, you know, hopefully a project that you can be proud of, you know, to show off and something that's really forced you to build your skills. So I just want to say how proud I am of you all and how great of a job you've all done. It's really awesome to see what you've built. Yeah, it's really, really awesome and great to meet a lot of you and get to know you as well. So I guess the only other thing is obviously, you know, most of you are part of the Queensland AI community. This course wouldn't have happened with the continued support and attendance of the Queensland AI community. You know, a lot of our attendees tonight are from the Queensland AI, are from this course, but there's a whole bunch more who are, you know, come to the meetups every month and support, and some of you speak at the meetup. So I just want to say thank you for continuing to do that, being curious, being eager to learn and be a part of the community, because I know that I've met a bunch of great people. You know, most of the people here as part of the course and the mentors have met a bunch of great people as well. So thank you for attending and making this great. And yeah, and hopefully we can continue to make it even better. So those are all my thank yous. I'm all thank you'd out. I think it is time to announce the winners. So I will come back to our what our winners win, and let's go through our chosen top 3. So thank you, Jeremy, Sue, and Jenny for judging tonight, for your thoughtful questions and taking some time out. All of the teams have done a great job, but there has to be some winners. So in 3rd place, drum roll, is What Would Twain Tweet? So this is one of our in-person teams, natural language processing. Great job, guys. I particularly liked both having classification and generation, and just the concept is very cool. Yeah, really cool idea, and love the little UI that you guys put together as well. In 2nd place, our 2nd place contenders are the beach cleanup team. So this is a computer vision team, another in-person team. Really great use case that has an impact, you know, obviously in the community, a great idea and very practical. Some of our judges also said that it was really cool that you reached out to the communities that could benefit, and yeah, really cool idea. I particularly like the fact that you guys you took some drone footage and put that in there and then converted that into something that people can take action on and go and clean up the rubbish. So I thought that was really cool personally. Well done, guys. Finally, the winners. In 1st place, it is our Nike logo obfuscation team, our last team that just presented. You have won the competition. Well done. Some comments from our judges is that it was a really well thought out project, useful application, and a great sort of real world use case. I personally thought that you guys deserve extra points for taking on the demo gods and winning by having a successful demonstration, which actually worked. So I think you get bonus points for that. But yeah, excellent job. Obviously, all of our finalists tonight will get an AWS swag pack. Everyone loves swag. So that will be a t-shirt, drink bottle, pen, basically so you can tell everyone who your favorite cloud vendor is. And obviously our winning team will also win some AWS credits. So I will be in contact with each of the teams on how you can claim those and any information that we will need from you. But yeah, amazing job from all of our final teams. I think every presentation was excellent. You've all done an amazing job, and you should all be very proud of what you've done over the last sort of 10 weeks. Really, really impressive. Hope to see you around in the Queensland AI Meetup. So that is all for tonight. Thank you everyone for joining us. Congratulations to the teams. Amazing job. And yeah, I think that's pretty much it. If anyone has any questions or anything, feel free to put them in Q&A. We will, yeah, that will be the end of the course. So we have a few minutes left. So I know there's a few people here who are interested in fast AI, who potentially have done the courses and are interested maybe in when the next course is. So from here, I'm going to, I think we'll open the floor for 5 or 10 minutes for any Q&A. This can be obviously from the teams or from anyone attending the course. If you do have any questions for Jeremy, feel free to post them in here. Yeah, take it away if anyone does have questions. And I might kick it off with the first one because everyone seems to ask this of you, Jeremy. When is part 2 of this year's course happening?
Not sure when part 2 is going to be. Hopefully sometime in the next two or 3 months. But nothing is set in stone at this time. While I'm chatting, I also wanted to just mention a couple of things about this, the scoring and the judging tonight. I think it shows how impressive the projects were, that the judging was actually very close. A lot of good scores across the board. But I will say, looking carefully at this, the winning entry was actually the top ranked entry from all 3 judges. So that was a unanimous selection. Big congrats for that. And we were all particularly impressed to see the live demo. It's not easy to deal with a real-time video stream. And so that was particularly impressive. I'd also like to mention, in fact, we all noticed the really strong kind of ML ops implementation of the semantic search book recommendations. It was great to see a full kind of front-end, back-end system put together, and very impressive to be able to put together such a complete system in such a short time. So congratulations to everybody. I also wanted to do a huge shout out to Michael, who has been tirelessly working both on the front stage, but also behind the scenes to make sure that every week has gone as well as possible. And he's been really passionate about making sure that this has been a successful course for everybody. And so thank you so much to Michael, and congratulations on making it such a success.
Thanks, Jeremy. I will also invite any of the other judges to speak if you do want to make any comments. Jenny, Sue, anything you'd like to share?
Yeah, thanks, Michael. I did want to just thank everyone. They really were terrific ideas and presentations. I really, wanted to call out things like the use of ensemble models. This is beyond the basics. So, congratulations for teams for looking at that. Data labeling seemed to be a common one. I would love people to have a look at SageMaker Ground Truth. It is a tool that makes data labeling very, very easy. And just finally, I wanted to call out multiple of these projects which we've seen could genuinely be productionized. They're not that far off being production. You've got the right idea. building additional accuracy in is really just a matter of more data, more time. And, you know, approach Nike and sell them a model, team. I reckon that they could use it straight away.
Yeah, thanks, Michael. I'll just add that it was great, although it was such the presentations were so brief and we had such a very short period of time to judge them. It was really great when teams actually included, you know, those live demonstrations. So I've been on there using the semantic search for book recommendations, putting in the descriptions of some of my favorite books, and it would have been great to have had a bit more time to be able to try some of those applications out. But yeah, very impressive that the teams in really such a short period of time were able to come up with, as Jenny said, almost production ready solutions. So yeah, congratulations everyone. It was fantastic to see how all of your work has come together, and thank you to the mentors, and yeah, thank you very much, Michael, for all of the time that you've put in.
No worries, my pleasure. Jem, if you are able to speak, feel free to share. But yeah, just one thing that I wanted to add as Jem from AWS gets ready is that, as Jenny mentioned, you know, a lot of these are close to production, and you know, for most of you, it's not that far of a stretch for these to be, you know, either a great portfolio item as you go for jobs, or you know, obviously just building your skills. But I think that one of the great outcomes from this is that you've all got something that you can show off. Jeremy mentioned last week at our last session that, you know, try and make one really amazing thing, the best thing that you can possibly make. And I think a lot of you have done an amazing job in this time. And there's something that, you know, if you were to apply for a job and you know, and your CV came across my desk, I think there would be, you know, a lot of these presentations that would be very impressive and make me do a double take and want to have a chat with you. So I think you've all done an incredible job.
Thanks so much, Michael. I just wanted to thank everyone for coming and seeing me every week. I'm going to miss all of your happy, smiling faces. If you are still interested in more information about our early careers, by all means, please reach out. You've got my details on Discord. And potentially, let's see what happens on part 2, whether or not I'll get to see you all again. But great work. I've really enjoyed spending my weeks with you. And thank you so much to Sue and Michael and Jeremy for allowing us to be a part of it. I've really enjoyed it. Peace out.
Thank you, James. Amazing. I think that's pretty much it. So, you know, virtual round of applause. I'm not going to clap, but virtual round of applause for all of our attendees, both those who made it to the final and those who, you know, didn't make it to the final 6. You've all put in an amazing job. You should be proud of yourselves. Not easy to commit this amount of time. So that finishes off this version of the Fast AI course. Keep your eyes peeled for the next iteration of part 2 of the course, which feel free to, you know, poke Jeremy on Twitter. I know he loves it, but hopefully around the end of the year, keep your eyes peeled for that one. We will look to do more of these in future. It is a lot of work to get it to happen, but we will look to do these again moving forward. So if you didn't make it or didn't have time to make it this time, you know, there will be more opportunities in the future. Of course, there's always a Fast AI course online that you can do at home. And you can also, you know, have a look at the GitHub repository, which I will share right now in the chat. If you would like to go back and watch a lot of the, you know, the recordings that we have gone through, and you would like to follow along with the course at a later date. Thank you everyone for being involved. It's been amazing to share this. That is the end of tonight's presentation. There will be another meetup announced for next month, probably in the next week or so. We have a machine learning engineer from Canva who is going to come and share some of the work that they're working on recommendation systems and engineering large-scale machine learning systems, which is not something you get to hear a huge amount of. So that should be a good one. I'm definitely keen for that. So keep an eye out for when that one goes up on Meetup, meetup.com. Otherwise, thank you everyone for joining us. Thanks everyone for being involved, and we will see you next time. Have a good night. Ciao guys.